discussed in this book, and that's Jack Serfati, who is a one-time mainstream physicist who I guess is known to some. He's very notorious in the scientific world. He started off in conventional physics, and I think in maybe the 1970s went off into rather unconventional directions and was co-founder, I think it was the Physics Consciousness Group, and I credit him in the book as being the inventor of the God phone. He says that, in fact, there was an earlier inventor of the God phone. But, we engaged in actually what was a wonderful dialogue this week, where he read the book in great detail, and he said, I agree the isomer bomb was a flawed idea. But he said, you're not really you're giving short shrift to cold fusion and zero-point energy and to psychics. And so I said, Jack, what's the alternative? What is your method other than peer review, other than scientific consensus to look at these results? And he said, I'll think about it. And that was actually a really wonderful dialogue, because my response to those on the fringes of science, and I think a lot of these people are well-intentioned, and that some of them may even be onto something, is that if you don't accept scientific consensus, please, for the rest of us, suggest an alternative. And I keep waiting for that alternative. So I do hope that some of these people on the fringes of science have something, but I think that we'll only know if they have something if they go about their work the old-fashioned way, which is reproducible experiments and theories that predict. As a whole, I like to say this book is about, a microcosm of the scientific underworld, but I try to address a larger theme, which is national security institutions and how they deal with science. The hafnium bomb many times is a very, very comic story, especially when we're dealing with, how a dental x-ray did or did not trigger this radioactive material. But it's also a much serious story about weapons of mass destruction and how the Pentagon deals with technical advice and how they decide which things are a threat and which things are not a threat. As I like to say, the hafnium bomb is funny, but imaginary weapons of mass destruction in Iraq are not very funny. And that there's a sincere lack of both technical expertise, I think, increasingly in the Pentagon, and an increasing unwillingness among those in the Pentagon and intelligence community to turn to scientists. A lot of the characters in this book, people who were senior scientists in the government, these positions, a lot of them no longer exist. The downsizing of the military in the 1990s, I think we lost a lot of our resident expertise, and we increasingly rely on defense contractors and outside boards for what should be internal advice. So, I guess what I've learned about the isomer bomb is two things. A, that we need some sort of scientific advice. We should not be beholden to scientists, but we should call on them when we need to. And the second thing, and I think this is the thing I'm still learning, and my thoughts on it are still being revised, is that we should never, ever dismiss something out of hand as being fringe. We should never say, oh, that idea sounds crazy, so it must be crazy. But neither do I think the scientific community does that. But we should explore and investigate outlandish claims. For me, the lesson of September 11th was I certainly thought that, no one would be capable, and certainly not Osama bin Laden, of coordinating, multiple plane attacks against the United States. I would have thought that claim was outlandish. And I think it took September 11th to really change my mind on that. Now, that being said, hijacking planes doesn't violate the laws of physics, but we should consider the unlikely. And that's another lesson of the book. And I really think that the scientific community considered the idea that an isomer bomb, a sort of new nuclear weapon, was possible. They considered it, they investigated it, and they rejected it. And the question is, why didn't the Pentagon? And I think that's all I have to say.
Could you talk a little bit more about kind of the larger policy implications, and especially as this current administration's attitude towards science in general and the formation of policy?
Sure. There's been a lot said about the how this administration, or others have written about how this administration has abused and used science to their own ends, that basically they have a policy goal and they would like science either to press on towards that policy goal, or where it doesn't agree with it, they simply disregard it. There's I think a good book on that called The Republican War on Science. For me, that's a different issue than what I look at. And I'm careful, while I think there's a very strong argument to be made that this administration has been very bad for science, and I think there are some multiple examples of that. I would be cautious to say that in general, on all issues, it's a Republican versus Democrat issue. A lot of what I describe in this book, the outsourcing of our resident expertise in the Pentagon, happened in the 1990s, not out of any nefarious purposes, but just out of the peace dividend when we were downsizing a lot of our military laboratories. I don't think that was done, to get rid of scientific advice. It was just done, it was sort of a negligent byproduct of it. Another thing that we've seen is a lot of the scientific posts that were in government, sort of senior scientific advisors as well as boards, have disappeared over the years. And that's something that long predates this administration. But certainly I think that there's plenty of examples under this administration where it's gone even further downhill. But I guess my cautionary word would be, we'll have a new administration in 2008, one way or the other, whether it's Democratic or Republican. And my hope would be that they really look at how we deal with scientific advice. When we have things like nuclear weapons or global warming, that whatever way you fall on the issue, that you be willing to look at what scientific consensus means. And I'm even changing my mind. What one physicist said to me is, one of the interesting things is, when does that scientific consensus flip? Like on global warming, at what point did that happen, and what does that mean? And so those are some of the things that I think we need to think about as we move forward. Is just how, in general, the government deals with science.
I wonder if you'd modify your statement that unusual claims deserve to be investigated. It's certainly true that in the case of Collins, which was on its face vaguely plausible because of the physical review letter, government labs spent a lot of money checking it and finding out it's nonsense. But claims of psychic powers and things like that, and the military efficacy of prayer and so on, I think those need to be dismissed out of hand. I would be very unhappy if a university or a government laboratory were willing to spend $10 million or something to investigate alleged psychic powers. And I wonder why the Stanford Research Institute, which supported Puthoff and Targ with their psychic claims in the 70s, why that institution still has a decent reputation. Its reputation should have been destroyed by its support of the research of Puthoff and Targ in the 70s.
Stanford Research Institute, which I now believe is called just SRI International, is a spin-off of Stanford, and it is a very, very reputable R&D research center, which has done some very, very usual, typical good things. They've also been out on the fringes. One example was Hal Puthoff and Russell Targ, who were under contract to investigate psychic phenomena for the military. I think it was in the 1980s up through the 1990s. I forget the years exactly. I haven't investigated it in detail. Hal Puthoff, the main guy in this program, just emailed me the other day asking me to look at some of his papers, and I will do that. I think one of the things you bring up is, what should science investigate? And I do agree that the starting point is science is based on natural phenomenon. So, questions of whether science should investigate prayer. Does prayer help health? I think that falls into the unnatural phenomena, and I think that the scientific community probably would not find it worth their money or their time to investigate it. There are certainly some theories out there, involving how quantum mechanics can explain psychic phenomena. Where does this fall? Should scientists be investigating it? Where there's a scientific theory, I guess I would kind of say, if some scientists want to do it and they can find people to support it that aren't a part of our national security institutions, go for it. Maybe there's something there. The question is, when does it rise to the standard of national security? Because again, as I said, the world is full of strange and wonderful things that, if true, could be worth investing in. What's interesting is I've spent a lot of time over the past 2 years, spending time with cold fusionists and, all sorts of people on the fringes. And they always say a couple million more dollars. Look at the results I have. And this was certainly what Hal Puthoff argued and those of his colleagues. We had these great results for psychics. And, my response is, well, you couldn't convince the scientific community. There's sort of the old standard, if you're a psychic, why aren't you rich? You've won the lottery. And there's always an explanation for why they haven't. Well, it's the laboratory conditions. It's very hard to replicate it. Well, okay, but at the end of the day, science is full of competing claims, and scientists are going to make decisions about which ones they want to spend their careers investing it in. My problem with the people who investigate psychics is they always had a reason for why maybe the laboratory conditions weren't really analogous to the real world. And all I can say is, from what I've seen, although I need to read the articles in greater detail, is they clearly weren't getting results that